You all. Today, actually, I am going to take a small lecture on one unit, humidification, and actually, I am missing you all in this lockdown. So we will try to utilize this lockdown. As you know, actually, I have to take 2 units. One unit is humidification, and other unit I have to take crystallization. If I get time, I will take also example on all the units in the crash course. But meanwhile, in today 20 minutes, I will try to engage some important points related to my chapter humidification. I think you know humidification is in the second section of my subject mass transfer 2, and in humidification, you know different applications are there. And after that, I will try to engage one lecture for crystallization also. So humidification start with the definition. Definition of humidification is that it is a mass transfer operation between vapor and gas, where mass of the liquid transfer from vapor phase or liquid phase. If it is transfer from liquid phase to vapor phase, then that is known as humidification. And if transfer from in another in opposite directions, when if transfer from vapor phase to liquid phase, then that is known as dehumidification. So like that, we are having it is a mass transfer operation. Then we will think about its applications. Mass transfer operation humidification is very very important in the cooling of the chemical plants. Some chemical plants may be hot. To cool the chemical plants, we require the humidification principles. Even for heating some buildings, we require these basic humidifications. When any cricket match starts, so during that also we require humidity, measurement of humidity, because humidity matters a lot to the environment. So we require humidity. Very important application of humidification is in cooling towers. In industries, in all industries, maybe small scale or large scale, we are using cooling tower, different types of cooling towers. And that cooling towers, basic principle, fundamental principle is humidifications. So in cooling on heating buildings, chemical plants, and mainly in cooling towers, evaporators, calendaria, spray pond, we require principle of humidification. So these are some application, industrial application of cooling towers. Then next we'll move to some important definition. In short, actually I will try to cover some definitions are there, important definitions are there, that like humidity, how we can calculate humidity. Humidity shown is of the two types. It is known as mass humidity. In humidification, we are coming across vapor gas mixture. So when mass of the vapor divided by mass of dry gas, that ratio is known as mass humidity, and it is shown by letter Y or YE. So PA divided by PB, that ratio is known as mass humidity. That mass humidity, if you convert by multiplying it by molecular weight, then it gives molar humidity. Molar humidity is also known as gross vapor humidity. It is given by scientists gross vapor humidity. Also, we are having important definitions. Relative saturation. Relative saturation means partial pressure divided by vapor pressure. This ratio is known as relative saturation. It is also known as relative humidity. Percentage saturation is also there. These important some terms are there of humidification that we have to second topic we have to cover in humidification chapter. After that comes very important topic, that psychometric charge. Psychometric charge we are using for the steam and actually steam means that is the vapor of the like water. Steam water combination we are using psychometric charge. From psychometric charge, if you know temperature only, then we can measure different parameters like relative humidity. We can measure only humidity. We can measure other parameters like relative saturations, relative humidification. Different parameters we can locate just by one diagram, and the diagram is known as psychometric charts. Psychometric charts, they are actually, it depends upon one basic temperature, 0 degrees Celsius. So this is our psychometric chart. Is also a very important topic we have to cover in humidifications. Next topic is their adiabatic saturation temperature. Adiabatic saturation temperature is shown by letter T and suffix AS. So it is a temperature when vapor gas mixtures get, when we are actually cooling vapor gas mixture, then it gets saturated. That temperature is known as adiabatic saturation temperature for that vapor gas mixture. So adiabatic saturation temperature is one of the important concepts of the humidifications. As we are in short time, that's why only I will just take this, but you go through that adiabatic saturation temperature. One equation is there, one relation is there. there that we have to do adapt saturated temperatures after cytometric chart. This is a very important topic. Then most important topic of this chapter is variable temperatures. Actually, what is the application of variable temperature? Variable temperature they are using in the industry to measure humidity. Humidity of the any vapor gas mixture we can measure only by knowing variable temperature and variable temperature both. So basically, simply we can define variable temperature at when thermometer is there and when thermometer's bulb is wet with the any oil or wet cloth also, wet wick also, then that temperature given by that thermometer covered with the wet cloth or wet wick is simply known as the variable temperatures. When the thermometer is bulb is open to atmosphere and it is giving temperature more than variable temperature generally. So always the variable temperature is always more than variable temperature. That temperature is known as variable temperature, DBT and WBT. So in Trebor book you will get one small drops and that's diagram is there, and in the above the diagram so one paragraph is there. It gives principle of variable temperature. Principle of variable temperature means what? How we can again define variable temperature. Variable temperature is a temperature at which if you cool vapor gas mixture, then that vapor gas mixture get saturated. Like that we can simply define variable temperature. But variable temperature, at the end of the variable temperature we are having Hg by Ky1 ratio. Hg by Ky ratio is known as wet bulb's depression. That is very important parameter in the variable temperature. So definitely this topic we will get for the your coming examinations. You just focus on this topic more. And in that we are having also one Lewis number. Lewis numbers means Schmidt number by Prandtl number. This ratio is known as Lewis number. For air water system, Lewis number is generally 1. So Lewis number is there, then Lewis relation is there. Hg by Ky is equal to Cs, where Hg means heat transfer coefficient, Ky means mass transfer coefficient, and Cs is known as humid heat. So in humidification we have two parameters, humid heat and humid volume. Humid heat means Cs and humid volume means Vh. So like that we can get that definition, simple definitions in the our Trebor book also. That very important topic actually I want to cover at the last part of the this humidification unit. That topic is known as cooling towers. So very important first thing is the cooling. What is the cooling tower? Why am I using cooling tower? Principle of cooling tower is the humidification. Humidification, cooling tower totally depends upon principle of the humidification, because when we are taking any drop of the liquid on our body, then their body parts get cool. Why? Because that drop, their body parts actually gives heat out to that liquid drops, by which that liquid drop get vaporizes, and due to that it extracts heat from that part of the body. That part of the body get cool. So like that we are this is principle of the cooling towers. Very important thing, cooling tower material constructions, they are using Douglas fir, they are using asbestos, they are using redwood. Redwood is a very common used in the industries for the material as a material construction of the cooling tower, because in cooling tower we are having continuous contact of the water with that wood at the cooling tower. That's why it must withstand in that continuous contact of the cooling tower with the water, and that's why it must be of the Douglas fir, redwood, or even asbestos also we can use nowadays. We can also use the polypropylene plastic also. Some cooling towers are plastics. Okay, but around 70 to 80% part of that cooling tower must be void, mean porous, and that's why cooling tower must be porous. Next, in cooling tower, different types of cooling towers are there. You will get diagram in the Trebor book, but we can classify cooling tower as cooling tower. Generally, we are having of two types. Broadly, we can classify cooling tower into two types. One is the natural cooling towers. If cooling tower is there, if you visit industry and if you get there in cooling tower, no fans are there, no blowers are there, then that naturally cooling take place. Then that cooling tower is known as natural draft cooling tower. So second type of cooling tower is mechanical draft cooling tower. In mechanical draft cooling towers, again we are having two subtypes. Number one, that cooling tower is known as induced draft cooling tower, and number two, that is known as forced draft cooling tower. So natural draft cooling towers, mechanical draft cooling towers. In cooling towers, if you use any pumps, blower or a fan, then it is known as mechanical draft cooling towers. And in mechanical draft cooling tower, again we are having two types. Number one, forced draft cooling towers and induced draft cooling towers. But they are asking one question, very important thing. In chemical industries, most common cooling tower is induced draft cooling tower. Induced draft cooling tower means what? In the cooling towers, if fan is at the top of the cooling tower, then that cooling tower is known as induced draft cooling towers. If fan in the cooling tower is at the side of the cooling tower, then that cooling tower is known as forced draft cooling tower. But in industries, induced draft cooling tower means cooling tower when fan is at the top of the cooling towers are very common in the industries, because efficiency of the cooling is more. Efficiency of cooling is more, plus recirculation of hot air is less. So that same hot air is not going again and again. We are getting fresh air in the indoor draft cooling tower as compared to cold draft cooling towers. So efficiency of cooling is very high in the indoor draft cooling towers. That's why indoor draft cooling towers are very commonly. Even a fan is at the top of the cooling tower now, then we are getting fresh air regularly in the cooling tower, and that's why these cooling towers, the indoor draft cooling towers are very commonly used. So naturally, a cooling tower generally we are using when humidity is very high. But so in UK or USA we are using national lab cooling towers. But in India or when in hot area, in hot part, actually generally these induced draft or cold draft, mechanical draft cooling towers are very commonly used. You will get a diagram in Trevor book again. Okay, so that topic is very important. In cooling towers are very important parts are that makeup waters. In cooling tower, principle of the cooling of the water, because cooling tower we are using to cool the hot water. In that cooling tower, we are using cooling tower to cool the water of the process industries, and that cooling tower get cool by means of the principal evaporation. So part of the water we are losing to the atmosphere, and that part of the water we are losing to the atmospheres. Even some part of the water goes with the air, so that is known as evaporation loss, drift loss. Different losses are there in cooling tower because cooling tower is open to the atmosphere, and that's why we are adding some part of water. With that cooling tower water loss is around 20 to 30%. So after 1 week or once a day, we are adding some water, 20-30% water as per requirements to maintain that level of the water in the cooling towers regularly, by which cooling efficiency will be maintained. And that water is known as makeup water. In cooling tower, another term is there, blow down. Blow down means what? In cooling towers, salt levels increases due to continuous use. As salt level increases, okay, that's why the water becomes hard, and even it gives scaling, algae, fungus, and that's why to maintain the water salt level, algae or fungus level to a certain limit, okay, we are letting out waters per week or per 2 days, per 3 days from the cooling towers, by which salt level or algae level or other levels will remain in the proper limits. So like that we are having blowdowns. In cooling tower, very important one parameter is there, approach. In cooling tower design mainly depends upon the approach. So what is meant by approach? Approach means what? Variable temperature of incoming water minus air temperature. Air temperature, that difference is known as, and that variable approach in cooling tower we are keeping between 2.5 to 5 degrees Celsius very commonly. These questions are asking very commonly in the gate examinations. Next, very important topic for your coming examination is the design of the cooling tower. Design of cooling tower you will get very in detail in the Trevor book or in Jean Copley's book. In that what jet we have to derive. We have to go for one cooling tower diagrams, and then we have to define STU. Already we have discussed STU in mass transfer 1, NTU in mass transfer 1. STU means what? Height of transfer units. Its unit is meter, and NTU means number of transfer units. Its unit is dimensionless. So we have to define Z is equal to, we have to actually derive that relation. Z is equal to, Z means height of cooling tower is equal to STU into NTU, and that derivation will get detailed because now it is difficult for me without a blackboard to explain to you that in detail derivation. Derivation you will get in the, but if I get time I will cover that in detail because it is a very important topic for industry also and your coming examinations. So Z is equal to STU into NTU. This derivation is very important topic of this chapter. So in short, in this chapter, two topics are very important. That psychometric charge, variable temperature, and cooling tower topic is very important. Especially design of cooling tower is very important. So like that we are having cooling towers definitions. In this, at the end of this chapter, we are having equipments for cooling towers. In cooling towers, we are having different equipments. Especially cooling tower is a very important equipment we have covered just now. Then spray ponds. If you visit sugar industry, then you will get that one fountains are there, and from that fountains we are getting sprinkler, and then what it sprinkles the waters, and due to that it lose part of the waters that by which water get cool. So spray ponds are there. We can use spray towers for the cooling of the water. We can use spray chambers. Very important thing you get in our home. We are using coolers. Coolers is very good examples. That is oriental chambers, spray chambers we are using. So like that we are having different calendria, heat exchangers we are having some in industries. Okay, we humidify the air, and that are very good example applications of the humidification in chemical industries. So it is one of the very important operations of the mass transfer, humidification. Okay. For our last, finally, about these examples, two examples are there. In the solid examples are there in Tremor book. There you go through the Tremor book examples, and one example is there. On the depends upon that is the design of cooling tower, in which we have to find out height of the cooling towers. That example, solid example, you will get in Jean Copley's book or even in Tremor book. Jean Copley's book example is very important. For this, you can use Tremor book. For this, you can use Becker Smith book, and for this, you can use KD Patil book. And RC Finance you can use for these chapters. Okay, like this, I will try to cover crystallization chapter on the video calls. You just go through the book, Tremor books, and try to cover these two examples only, two small examples in the Tremor book, and one example from Jean Copley's on the cooling tower design, in which we are finding Z. Okay, just go for these 2-3 examples. You will not get any other examples out of these 3 examples, except these 3 examples. So again, I wish you all the best. Okay, it become compulsory for me to take the lecture on the video calls. Again, I will try to interact with you. Okay, because I'm having lots of knowledge, and it become very difficult for me to cover this in just this specific minute, specific hours. I'm having constraint in my homes. Okay, my daughter, thanks to my daughter Ojasvita, she is her sister Shravani, they are recording this all the things. It's my kind request. You take care of your family. You stay at your home, stay safe, and again, missing you a lot. Okay. Try to prepare yourself, because it is one of the important subject of your whole career, Mass Transfer 2. We have actually, I think you know, we have prepared one WhatsApp group. If you get some difficulties there, we can interact there, we can discuss. Okay, again, wish you all the best. Stay home, stay safe. Thank you one and all. Thank you.